just putting Band-Aids on, a fundamental problem. It's like putting a Band-Aid on a broken arm. It's not going to fix it. The bleeding might not, the scrape might not be visible, but the arm's still broken. And physical connectors just are fundamentally flawed.
Okay, Jacob, I often hear customers and NuCurrent team members lamenting over connectors and how much they suck. People are talking about it so much that I'm starting to believe it. And I'm just wondering if you could elaborate on why connectors suck so bad.
Yeah, connectors do suck. They have sucked for decades, but it's become a necessary evil. I mean, every electrical, mechanical, basically electronic device designer, it's just the way that you put power and data into a device and take power and data out. So whether it's pogo pins, USBs, HDMIs, whatever it is, these input and output connectors have just been the norm. But they absolutely do suck, and it really boils down to one big thing. And that's the connectors are usually, almost always, the number one cause of failure or weakness in any electronic device. We've seen this across so many industries, from rugged computing like industrial handhelds to earbuds to wearables. I mean, connectors suck. They do. They're terrible. And so because they're so frail and because they're the number one cause of damage, it leads to some major costs in the system that we're really trying to address at NuCurrent with contactless connectors or wireless connectors.
Yeah.
So I wanted to talk a little bit about the types of costs. So there's direct costs, and then there's indirect costs. So from direct costs, we like to talk about the warranty claims and repair costs that come when customers say, my device is broken, what's wrong with this? You need to replace it, you need to fix it.
Yep.
That's expensive. Second direct cost would be product recalls. This doesn't happen very often, but when it does, it can be catastrophic, on the orders of tens of millions or hundreds of millions of dollars of direct costs, not to mention the indirect cost of brand reputation we're going to get into a little bit later.
That's scary,
yeah, for sure. It's very scary for companies, and it's something that they work really hard to prevent. So product recalls can be extremely expensive. Kind of in a similar category, you can have lawsuits, and so we saw this with Beats. Beats had a lawsuit against them, or I guess Apple had a lawsuit against them for their Beats products because of poor charging based on physical connectors, and I think it was called their Beats Pro. So these are real risks that are happening right now in electronic devices, costing tens of millions of dollars to companies for because of connectors. And then finally, replacement of defective units is another direct cost that really adds up when this is the top failure of many products. On the indirect cost side, we have brand reputation and damage. Obviously, when your device stops working, you start thinking the device has shoddy quality. The perception of that brand and that product goes down.
Big time.
Yep. Customer dissatisfaction and lost sales is a result of that, but also negative reviews. Reviews are such a big thing now. With the difference between a 4.7 star and a 4.5 star review could become millions of dollars of sales. And when you have negative impact from charging, or people wake up and one earbud didn't charge and then the other one did.
Yep, the worst.
Negative review.
Yep.
It reduces the product lifespan, and so this is one of those double-edged swords. I mean, there's a lot of conspiracy theories out there that companies design for planned obsolescence. You can't sell a new phone if the last one's not, shoddy.
Yep.
But in reality, all the OEMs that we work with, they really want high-quality products that last a long time. They're not trying to plan in obsolescence. So, assuming planned obsolescence isn't the strategy, then you want to avoid the failures that come with connectors, because it really does reduce the lifespan of a product. And then finally, this gets overlooked a lot because it doesn't really hit at the design level. It's not part of the E-BOM. It's not part of the manufacturing. But something that really does matter is connectors lead to a lot of phone calls and a lot of emails that get sent to customer support, and it's a major customer support cost. We did an assessment of one of the largest earbuds products, and we assessed that over $1.50 per product is for customer support.
Wow.
Which is pretty crazy when you think about that they have to attribute that much cost to a physical product that theoretically should never have a phone call or a visit to the store associated with it.
Yeah, exactly. So it's clear that connectors add, cost, and they're a huge weak point in a lot of products.
Mm-hmm.
What are engineers actually able to do about it?
Yeah, so they're, because they've been around for so long, there are very standard techniques for trying to mitigate the failures. But ultimately, it's really mitigation, which means you're just putting Band-Aids on, a fundamental problem. It's like putting a Band-Aid on a broken arm. It's not going to fix it. The bleeding might not, the scrape might not be visible, but the arm's still broken. And physical connectors just are fundamentally flawed, and in a few ways. So, I'll talk both about what the fundamental flaws are, like why they break so often, but then what engineers try to do about it.
Great.
But what I think everyone should keep in mind is that when they try to mitigate these failures, they're just adding more cost to the system, because anything they do to mitigate is an addition. It's an additional step, it's an additional material, it's an additional process, and all of that adds a cost. So I'll just list out what those failures are, the typical failure modes.
Gotcha.
So the typical failure modes for connectors include corrosion and oxidation, which is when the connectors are exposed to moisture, and over time it corrodes, which leads to an increased resistance, which can lead to runaway thermal effects, and it basically breaks the device and the connectors. Mechanical wear is very common, especially in any kind of connectors where you have a lot of mating cycles,
Mm-hmm.
so where you're plugging it in frequently, or in connectors where there's a lot of vibration or movement in the environment. You'll just wear down the connectors because there's friction.
Yep.
Fretting is that's related to micro motion, so that's when there's really small movement that kind of wear them down over time. Thermal stress comes from temperature, which can come from resistance, either due to things like corrosion, or there can be foreign materials that add resistance that lead to heat. That's a very common cause of failure. Contamination is something that we see a ton in wearables and hearables, because you get water, sweat, dust, dirt, debris. An interesting one will be sweat, because sweat has a lot of salt in it.
Yep.
And so what that salt actually will do on the contact of an earbud is it actually dries and then starts creating a wedge in between the plastic and the plated material.
Okay.
And then once it creates that salt wedge, now water can go in and it starts breaking the device.
Gotcha.
Yeah.
Okay.
And then let's move over to what people do on the side of mitigation, which is what you asked before.
Sure.
So the typical processes are designed for reliability. So just try to create more robust designs, thicker materials, tighter tolerances, more gasketing. Those would be examples of how to design for reliability. Again, listen, it's all more. Mm-hmm. Throw money at it, right? This is what they're doing. Yeah. Material selection. So obviously always try to pick the best materials for the environment, but that doesn't always mean the cheapest or the,
right.
And you have to pick specific materials because of your connectors, which in an ideal world, the connector shouldn't be your major design constraint. It should be, what's the user experience?
Right.
Then we'll pick the right material for that. We don't have to think about how we drill, precision holes for plastic, molding for the pogo pins to fit in perfectly.
Yep.
Testing and validation. So much testing and validation, and spraying these with all sorts of water jets just to see where they break, and then when they break, try to fix it with design for reliability. It's a vicious cycle, and some companies have gotten pretty good at it, but it's an expensive process, and it really slows you down to get to market. Quality control is big, oftentimes with connectors. However, when you're doing quality control and these products get to the end of the line, so think about it, you're putting together an earbud. It has all this automated process. It gets to the end of the line and they're testing it for quality, and the connector doesn't have a fixed seal. So it's a yield loss right there. They have to throw it in the bone pile, meaning it's out of commission. At that point, they can't really take apart the earbud and reuse the parts.
Yeah.
They just wasted the speakers, the microphones, the semiconductors, all of that.
Gone. Yeah.
And so that's expensive. It really adds up. Quality control is super important so that you avoid some of those problems that we talked about earlier with brand perception and negative reviews. You have to do quality control. However, it's just spotting the problems before your customers do. It's not fixing the problems.
Yep.
Stress relief and redundancy also kind of round that out. So out in line, connectors absolutely suck. They've become a necessary evil. There's been a lot of systems that have come into place to try to work with that old technology that's very imperfect, but all of it comes at a cost, and it's important for people to understand there's a better way, and that better ways available today.
Okay, awesome. Thank you.